In this problem, we're given function y equals x cubed sine 3x, and we're told to find the derivative of y with respect to x. Now, fundamentally, this is a product, x cubed times the sine of 3x, and the sine of 3x is also a composite function, 3x being the inner function and sine of x being the outer function. So to find the derivative, we need to use the product rule and also the chain rule. So here's the solution. dy dx will equal the derivative of a product. And so I will do the first times the derivative of the second plus the second times the derivative of the first. So the first is x cubed. Then the derivative of the second is cosine 3x times 3 by the chain rule plus the second, which is sine 3x, times the derivative of the first, which is 3x squared. And then we can simplify this a little bit by factoring out the 3 from each term and factoring out the x squared. So I'm going to write 3x squared, and that leaves me with, in this first term, that leaves me with, let's see, x times cosine of 3x plus, over here, if I factor out the 3x squared, I'm just left with sine of 3x. Okay, so that's the answer. And these two terms right here, of course, because they're just added together, those could be reversed, or you could switch places with those if you need to match one of the given multiple choice answers. Okay, so that's not a hard problem, but two distinct concepts dealing with derivatives show up there, the product rule and the chain rule. So just remember, when you differentiate a product, the derivative of the product is the first times the derivative of the second plus the second times the derivative of the first. And then when you differentiate a composite function, this sine 3x, you differentiate the outer with respect to the inner and then multiply by the derivative of the inner. Product rule and chain rule.